Hello everyone, welcome to my class. Today we are going to discuss electric components. Okay, so these are the topics we are going to discuss. Common components, resistors, current, voltage and power, calculation of resistors and resistors power rating. Mainly, we will focus today on resistors. So let us see the common components. So resistors is the first one. This is how they look, the appearance, and these are the symmetric symbol or circuit symbol. Then capacitors, there can be two types, non-polarized or normal capacitor and polarized capacitor. So their circuit symbols are like this. Inductors is coil, transistor, this is an active device, diodes, okay, light emitting diodes, conductors or the cables is the circuit symbol like that. IC integrates this also, sometimes they are active. And battery or the generator, they are active components. Insulator, to insulate the conductors to avoid any kinds of injury. Then the resistors. So as we can see, the appearance is this and their circuit symbol like that. They are two lead or two terminal or two hand, whatever we say, components. And the characteristics of resistor to oppose the flow of current in a circuit. Means by doing that, we can use resistors to regulate the current flow in a circuit. Okay. And to maintain a constant relation between current flow and voltage. Now, two lead components as usual, and then we use this one to control the electric current flow in a circuit. Now, the greater the resistance value, the less will be current flow. Okay, because they will resist more. The unit of resistor is ohm, and usually sometimes in a circuit or the value is written like that. 10 ohm means 10 R. 0.1 ohm means 0 R1. 1000 ohm means 1 K or 1 kilo ohms. How we read the value? We can see from here, there is some color. Okay, so these are the color band. The stripes are known as color band. So using a color code, we can read the value of resistor. What we will discuss after this. Okay. So now the resistors, they are the symbols. These are the usual resistors we use mostly. This is their symbol, circuit symbol. This is the power resistor, used for high power, to dissipate high power. So their circuit symbol also is the similar. And then LDR, light dependent resistors, means their circuit symbol is like that and the appearance is like this. And the variable resistor, which we can tune as one need for various application, they looks like this. Okay, the appearance like this, and this is the circuit symbol. Now the application mainly limiting the current in electric circuit or control the flow of electricity in a circuit. By doing that, lowering the voltage level in electric circuits. Okay, sometimes we use voltage divider. Also, as current provider, means in a specific amount. It can be used as a sensor too. So, for example, there are photoresistor. This can detect the light condition. Thermistor detects temperature, and strain gauge detects load condition. Sometimes in electronic circuits, resistors are used as pull-up and pull-down elements to avoid floating signal levels. Now let us see the color bands and color codes, how we can measure the value of resistors. Okay, so usually or mostly use the 4-band color code of resistors. So first, let us see what are the 4 bands. Okay, we can see here the color, and depending on that, they have a value. It is worldwide known. Okay. So black is 0, and brown is 1, red is 2, and so on. None means there is nothing. Okay. So until white, 0 to 9, they have the value. But there are 3, gold, silver, and none. They don't have value for the first and second band. This is the first band. This is the second band. This is the third band. First band is the value. Okay. Digit, first digit of the register value. Second one is the second digit. Third one is the multiplier, 10 to the power, or we can say number of zeros. Okay. Fourth band is the tolerance. What is tolerance? I'll discuss next. And fifth band is the temperature coefficient. So these are the color bands. And there are 3, gold, silver, none. They are only used for the multipliers and the tolerance. Now, this is a 4-band register, as we discussed. 1, 2, 3, 4, because there are 4 stripes of colors printed on it. 5-band, 5, and 6-band, 6. How is the value? As we discussed, first color is first value, first digit. Second digit, second color. Third one is multiplier. Fourth one is tolerance. This is for 4-band. For 5-band, is the first 3 are the first 3 digit of the resistance, means the value of the resistance. The fourth one is the multiplier. And fifth one is tolerance. Whereas for the 6-band, similar to 5-band, first 3 are the first digit, second digit, third digit, value of resistance, fourth multiplier, fifth is the tolerance, and sixth is the temperature coefficient. That's the extra. Now, how do we know? For a real resistance, we will start to read the value from this side or from this side, means from left or right. So, the rule is the direction of measurement is using the gap. So first 3 will be very close to each other, means they are the value of the resistance. These 2 value, this is the multiplier, means total together is the value. There is a gap, means we have to read this first, follow the gap to get the tolerance or temperature coefficient for 6-band. Yeah, they are close together or equally placed. Then there is a gap. So this is the way direction of measurement to measure the value of the resistance. Now let us see what is tolerance and what is temperature coefficient. When we measure the value of a resistance, it is the nominal value or the measured value. Now this value is not exactly same most of the cases, because due to reading error or measurement error. So there can be some kind of plus and minus tolerance. So the tolerance is written, the plus and minus, which we will discuss later. So for example, if a resistor nominal value is 100 or measured value is 100 ohm and tolerance is plus minus 5%, is written plus and minus, can be the value more than 100 or less than 100. So let's see how is this 100 tolerance 5% means what is the value, actual value of this resistance. The value of the resistance can be minus means 95 if we and then plus 5 means 105. So the value can be any within 95 ohm to 105 ohm. If tolerance is 2% of a resistor or less, means it is a very good or precision resistors. Okay. And depending on the tolerance, we have to choose for different application which resistance is more usable. And now another one, temperature coefficient. Okay, the temperature of a resistor vary depending on the resistance of a resistor vary depending on temperature. Okay, variation of temperature. So if the temperature increase or raise, the resistivity value also raise. From here, we get the temperature coefficient, mean how much the variation of the resistivity value depending on the temperature. That is the temperature coefficient. So resistor temperature coefficient of a of resistance is TCR, known as is the actually the change in resistance value per 1 Kelvin change in temperature. And the unit of this ppm means parts, how much the change of resistance value per million per degree centigrade, means divide by 1 million per degree centigrade. So ppm per degree centigrade. This is the unit. If the temperature changes by 1 Kelvin and with a 6 band, here we can see, okay, is not yellow, it's the brown. Brown means what's the color? 1. So it will be, okay, the temperature change is 100 ppm. So it will be the change 100 parts per million in resistance. If it is yellow, then it will be, yellow value is 25 ppm, means 25 parts per million per degree centigrade. So means either 25 or 100 per million is the band is very good and found is a precision resistor. Okay, now let us see how we can read. This is a 4-band resistors. So there are 4 stripes of colors. We mark this A, B, C, and this is the tolerance. Tolerance means this is the error, okay, in the value, measured value. So this resistor value of this first digit, second digit, AB, third one multiplier can be put 0, 0 or 10 to the power C, and the fourth one is the tolerance. So tolerance plus minus, usually we write with plus minus, what is the value? This is the ohm. This is the value of the resistance. Now let us see. First band is yellow. The value of yellow digit is 4. Then violet. Violet is 7. Then red, and this one gold. Okay. So red is 2, means 10 to the power 2. This one the multiplier, and gold is plus minus 5%. Okay, so let us see this one. The third band is red. So this one the multiplier, this one the first digit value, second digit value, this is multiplier, this is the tolerance. Tolerance means plus minus 5%. So the value is 47 multiplication 10 square 10 to the power 2 plus minus 5% ohm. Okay, we can measure the value using multimeter, digital multimeter also, but and the tolerance is how much error during the measurement. Okay, this is the 4 band. Now let us see another example. This one also a 4 band resistor. First value is green, second value is blue, third value is yellow, this one gold. Gold means plus minus 5%. So from our table, okay, color code, green is 5, value is 5, blue is 6, yellow means just 10, means yellow is 4. Okay, yellow is 4. So this one yellow means 10 to the power 4. It's a mistake. So the value will be 56, 10 to the power 4 ohm, and this one plus minus 5%. Now let us see the 5 band resistor. How we can measure the value of the 5 band resistor? Here first value is red 2. First 3 is the value, digital value. Fourth one multiplier. Fifth one is tolerance. So first is 2, red. Second one is the orange, 3, violet, 7, black means 0. So 10 to the power 0 means 1. This is the value. And the tolerance is red means plus minus 1%. So, okay, 2%, plus minus 2%. So this one is the plus minus 2%. There are also third band. What is third band? Is actually the fourth band, but the only 3 stripes are there. Fourth one is missing. Fourth one missing means we can none. None means the tolerance will be plus minus 20%. So first digit is brown. The value is 1. Second digit black 0. Third digit is the multiplier because it's a 4 band actually. Multiplier. So its value also is 1 means 10. Okay. So 10 means the value is 10. Here multiplier is the value is 1, 10 to the power 1. Okay. So brown means 1, so 10 to the power 1 multiplier. Okay. And black is 0. So 0, and then this one is 1, multiplied is 1, so 10, just the 10 plus minus 20%. Okay. These the actual registers. Why I put here? I put here how we will measure. We will measure the value of the resistivity from here to here, this direction, or from means left to right or right to left. It depends. We can see from here, these 3 are equally spaced, very close to each other, means this is the value of the resistance. Okay, this is the first digit, second digit, multiplier, then this is the tolerance. Gold means plus minus 5%. Okay, and here is the value. This one we can see 3 band, means there are 3 patch of colors printed on it. So that's why here is the gap. Here is gap, means tolerance is here none, plus minus 20%. So this one the green, the value is 5, red is 2, and then blue is 6. Okay, means 10 to the power 6. So this one is 52 into 10 to the power 6 plus minus ohm plus minus 20. So let us see here more clearly. So 4 band color code, this one the first digit, this one the second digit, this one the multiplier, this one the tolerance. So from here, first is 2, red is 2, second one is green 5, so 25, third one is orange, the value of orange 3 means 10 to the power 3. Okay, so 10 to the power 3 means kilo. So 25 kilo ohm. This one is gold plus minus 5%. 5 band, first 3 are the values of the resistance. This one is the multiplier. So yellow is 4, blue is 6. We can see. So 46. Black is 0. So 460. Next is orange. Orange is 3. So 10 to the power 3 means kilo ohm. And this one is brown. Brown means plus minus 1%. 6 band is first is red, value 2. Violet is 7. Blue is 6. 276. Black is 0. So 10 to the power 0 means 1. Okay, we can use either 10 to the power or like that. 0 is 1. So 276, just as you are ohm. This one is gold. Gold is the multiplier, and this one is the temperature coefficient. This is brown. Brown is 100 ppm. So we can write here, comma, 100 ppm. Okay. So again, some more example. This is a 6-band resistor. What we can see, first one is the first value, first digit. Red is 2. Second one, violet, 7. Third one is yellow, 4, 274. This one, the black, 10 to the power 0. Black value is 0. Okay. So this, and then this one, the tolerance. Tolerance is red, means plus minus 2%. Temperature coefficient, black means 250 ppm per Kelvin. Okay. Or the per degree centigrade, whatever we measure. So this one, 250 ppm per Kelvin after comma. How we can write? Now from here, if there is a 4-band means these 3 value. You can see equally spaced. They are equally spaced. This one is the tolerance and temperature coefficient. Equally spaced. These are the value, resistance value. This is the tolerance. Okay. For 5-band, these are the equally spaced, the spaced values. This is the tolerance. Okay, so this one we can see the brown is 1. We can see from here clearly. Red is 2. Green is 5. So 1, 2, 10 to the power 5 means 1200 kilo. Okay, we are putting, and this one is the tolerance. Gold means plus minus 5%. Let us see this one. How is this? Actually, first one we can see is the brown. Second one 0. This one 0. So 1, 0, 0. This one multiplier 2, 10 to the power 2. And this one is the brown, means plus minus 1%. So this one can be written 10. Okay, this one means 10,000 ohm plus minus 1%. So this is how we can read the value of resistance. Next, another one, depending on the metal used to depending on the metal used for a resistance or for a resistor or a cable or conductor, we can calculate their resistivity value based on the characteristics of metal. So let us see, this is a conductor. So the value of the resistance depends on the length, okay, how long the conductor is, and the cross-sectional area of this. So R equals rho L A. Rho is a constant, is the resistivity coefficient of the metal. So L is distance in meter, A cross-sectional area in millimeter square. From here, it is very clear that the resistivity value or the resistance is directly proportional to length. Length is more, resistance value will be more, and inversely proportional to the cross-sectional area, means if it is very thin conductor or the cable, the resistivity value will be more, or if the cross-sectional area is more, resistivity value will be less. Depending on that, we can choose what type of cable or the conductor we will use. Okay, now let us see one example of the calculation of resistance value. Suppose this one, the length is given 3200 meter, should be always in meter, and cross-sectional area is given 240 millimeter square for a copper cable or conductor. So how is this? R equals rho. Rho for the copper is 1/56. We can see that one later in a table. Okay, we can get all the values from a table. And then L divided by this. So 0.238 ohms is very less. Okay, because the metal resistivity is very less. Okay. So this the raw value for the copper, and this is the table. From the table, we can measure all the values. Now we can mark here this is the coefficient rho resistivity coefficient. This is the resistance value calculated using the formula. So for silver 0.00094, this is very less, means it's a very good conductor. Next, coming to copper, then gold, aluminium, which are the 4 very good conductors used for making circuit. Now the power rating, okay, or the relationship between power, voltage and current flowing through the circuit or through the resistor. So when current flow through a resistor and the resistivity value is very high, electric energy is converted into heat and sometimes light also. Okay, means it do work. Okay, so that's why our lamp, okay, or electric bulb give out light. And what we can mark here, that the filament of the light bulb is very thin. Very thin means, according to our formula, resistance value is inversely proportional to the cross-sectional area. So its resistivity is very high, means it resists to flow of the current through it. Due to this friction, the light bulb give out the light. Okay, and at the same time, and the heat. Okay, so now the power dissipated or consumed by a resistor or equivalent resistance in a circuit or network can be calculated P equals I into V, or we can use this triangular formula to make it easy. Okay, and we already know the relation between the voltage, current and resistance, that using the Ohm's law is V equals IR, okay, which can be written in 3 forms: I equals V by R or R equals V over I. If we combine this, okay, this with this power law, we can get the first one, P equals VI, second one, V equals, if we put IR, this one will be I square R, or I equals V over R, this can become square by R. So this also can be in 3 forms. 3 different forms we can express and we can use as per our need. Now let us see the examples of power rating or power dissipated by a resistors. So for example, what is the power output of a resistor when the voltage across it is 6 volt? So this is the value of V, okay, and the current flowing through it 100 milliampere. This is the value of I. So it's easy. We can just use the formula P equals I into V, means I is 100 milliampere. This one 6 volts, 600 milliwatt means 0.6 watt. So this is the power consumed or dissipated by the resistance. So if we write the power rating on top of the appliances like this, there will be a little bit more than that. So let us see in other examples that what can be the power rating of a 460 ohm resistor. This is the R value, okay, with 10 volt across it. This is the V. So here is given R and V. So not this formula. We can use the formula. We can use the other formula, P equals V square by R. Okay. So V is 10. So 10 square divided by 470 is 0.21 watt. Now this is the power dissipated or consumed by the resistor. How we will write the power rating on a device using this resistor? So in this case, the standard is little bit markup. Means rather than 0.21, it's written 0.25. Okay, this would be suitable. We cannot mark up too much. also not too low. So just nearest to one. Okay, nearest in a standard value. So let us see in terms of another example. Power rating of a 27 ohm resistor with 10 volt across it. How we can determine? Determine here also given R and V. So we will use V square over R is 3.71. It's a little bit high voltage. So it can be written in terms of the integer value. 4 will be very close. So next value is 5. Okay. 6 will be again higher, very higher. And if 6 voltage is higher than 6 or little bit less than 6, maybe there will be damage to the circuit or the resistance. It may be affected. So suitable one is 5 watt would be very suitable. So resistor in power supply usually designed to dissipate an amount of power. This power should be regulated very this power actually should be regulated very carefully. Okay, if the average power dissipated by a resistor is more than its power rating, then the circuit will be damaged permanently and the resistance value can be changed. Okay. So example of power rating as practical which we use in our everyday lives like light bulb. So if written on it is 60 watt, okay, so how much current can flow through this light? We can use that one P equals IV, that one is following, and again we can use high mass current P over V, I equals P over V. So V is suppose the outlet voltage in our household appliances. It's the AC voltage usually in our from the socket of our household wiring. So I equals will be P over 5. So P over V, so it's 0.5 amperes. For 100 watt bulb, again I equals P over V means it will be 0.83 amperes. So from these two we can see here current flowing very less. Here a little bit more than this means the resistivity is more here. More for the 60 watt than the resistivity for the 100 watt. Is this one very thin filament, this one little bit thicker than this. Now for the, so that's why it's give light. Now let us come for the kettle. Kettle, if the power rating is 900 watts for the same household appliances or for the same household AC outlets 120 volts for all appliances. So this one I will be 7.5 amperes. So it's more because there is a coil and we can see it's become red, giving heat to boil the water, but it's not giving light because it's thicker. The resistor or the coil is thicker. Same goes for electric toaster. It also gives the heat to toast our bread, but it doesn't give light because the cable or the resistor is thicker. So suppose the power rating is 1200 watt, means the current flowing through it is 10 amperes. And we have to be very careful. We cannot exceed the power to use these appliances. Otherwise, they will be short-circuited and damaged. Okay, so let us see one example how the electric bill is calculated for our everyday uses, household uses. So monthly payment, how much the energy consumed by a lamp, we can see here. Okay, like this is one example. Okay, so from the household AC voltage supplied 220 volt for this case. Okay, and for one bulb, if the current flowing through the bulb is 5 amperes, how can we calculate how much work done or energy consumed? First, let us see the formula for energy consumption. Energy E actually is power, dissipated power by this bulb or resistor in the bulb multiplication the time, how long it's working. Okay, that's the power E equals PT, and this actually also with the help of this V equals IR and P equals IV, we can get or calculate the values. So P is here, okay, and V here is here. We can get. So the energy or the work done equals P into delta T, P IV, V IR. This is the EG. Now, for this example, let us again see the charge, electric charge per kilowatt hour. The energy is kilowatt hour. Okay, we can see because this one, the P is the watt or kilowatt power, time is hour in terms of. So 12 cents per kilowatt hour, if the price, how much we have to pay for the use of one light bulb in 1 month. So now power equals voltage into current, VI. V is 220 volt, here is given, and current is 5 amps. So 1100 watts. Now energy E or work done equals P into delta T. So P is this one, delta T is the time duration, 24 hours a day, 30 days a month. This is the total time. So if we multiply, total is 792,000 watt hours. Okay, or we have, after converting to kilowatt, 790.2 kilowatt hour. Now monthly payment for 1 kilowatt hour is 12 cents. So multiply by 12 cents per month is 90.504. This is the bill we have to pay. In our case, in Malaysia, is the Malaysian ringgit. But if it is in US, it can be USD. So that's all. Now let us summarize what we have learned. Resistor, it's a two-lead passive components and used to control the flow of electricity in a circuit. And then resistance is the property of resistor, how much it opposes the flow of current. So here two example, conductors are very poor resistor while insulators are excellent resistor because they don't allow electron flow at all. Now how we can measure the resistivity value? Using color code. If written on the resistor, then we can get directly, or using multimeter, or the formula, using the formula based on the metal characteristics and used metal. Okay, then another one, power rating. Power rating is the maximum power a resistor or load can tolerate without any damage of it. And this one is very important for safety of electronic circuits and components or devices we use to prevent the permanent damage. And the power rating or the energy consumed equals PT. So these three formula we have to keep in mind and easy to remember, all in the same nature. E energy equals P delta T, time consumed P IV VIR. This is very, very important for our electric and electronic devices. So in the next class, we'll discuss the rest of the components as usual. So that's all for today. Stay tuned. Thank you for watching. Bye.